Decision tree. A common and obvious way for classifying an instance is from a sequence of questions, so that next question is asked with regard to this current question. Using trees are the most common representation way for thesis question answers. Decision tree is used to create a classifier ensemble, expansively. Also, they are used for the application of data mining and clustering. Their functionality is understandable for human. Besides, unlike other methods such as ANN, they are very quick. It means their learning phase is quicker than other methods. Duda, 2001. Different structures of decision trees are described in Bryman, 1984, Duda, 2001. One of the most important specifics of them is that each node asks a question only on one feature. In this paper, a new classification method is proposed which operates like decision trees, however it makes decision over all features. K-nearest neighbor. Nearest neighbor techniques are simple but powerful nonparametric classification systems, Darasay, 1991. The simplest version of them is single nearest neighbor. It bypasses the problem of probability densities completely and simply classifies an unknown sample as belonging to the same class as the most similar or nearest sample point in the training set of data. Nearest can be taken to mean of the smallest Euclidean distances in n-dimensional feature space. Although Euclidean distance is probably the most commonly used distance function or measure of the similarity between feature vectors, it can be used from other metrics like Manhattan or maximum distances. A more general version of the single nearest neighbor technique bases the classification of an unknown sample on the votes of k of its nearest neighbor rather than on only its single nearest neighbor. The k-nearest neighbor classification procedure is denoted by KNN. If the costs of error are equal for each class, the estimated class of an unknown sample is chosen to be the class that is most commonly represented in the collection of k-nearest neighbor, Doza et al., 1996. In this paper, the KNN with the Euclidean distance is used as a base classifier.